Hello, I am Arlissa with 8-Minute Maths, and in this video we will be factoring cubics using the rational root theorem. A cubic is when we have ax cubed plus bx squared plus cx plus d equals 0. When we're trying to utilize the rational root theorem, we find that a sub 0 equals this a term, or the coefficient of this first term. And a sub n equals the constant, or this last term. The rational root theorem is plus or minus a sub n divided by a sub 0. And we're going to talk a whole lot more about this in a minute, but I wanted you to know how we use these things. So let's do an example with some numbers so we can see how these things make more sense. X cubed plus 6x squared plus 11x plus 6. So here we have, there's an invisible 1 as this coefficient. So a sub 0 equals 1. And then a sub n equals 6. What we want to find is what are the factors of a sub 0 and the factors of a sub n. Well, the factors of 1 is only 1. The factors of 6 are 1, 2, 3, and 6. So utilizing the rational root theorem, plus or minus a sub n over a sub 0, we have a sub n, we have 1 over 1. And then we have 2 over 1, which is just 2. We have 3 over 1. And we have 6 over 1. So our roots are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. These are the 8 roots that are possible for the solution of this cubic. So let's see, if we were to substitute, what we want to do is see which one of these numbers, when substituted back into this cubic, actually equals 0. Let's try positive 1. We're going to use positive 1. See what we come up with using positive 1. Well, we've got x cubed, so 1 cubed plus 6 times 1 squared plus 11 times 1 plus 6. Does that equal 0? I think we can all tell right away that it doesn't equal 0 because all of these are positive, and when you add all these things up, this does not equal to 0. Well, let's try negative 1. So if we had negative 1 cubed plus 6 times negative 1 squared plus 11 times negative 1 plus 6, does that equal 0? Well, negative 1 cubed is negative 1. Plus 6 times negative 1 squared is a positive 1, so that's 6 times 1 is 6. Negative 11 times negative 1 is negative 11. Plus 6, does that equal 0? Well, negative 1 plus 6 is 5. Minus 11, putting all three of these together, we have negative 6 plus 6, and that does actually equal 0. So negative 1 is one of the roots of this equation, or this cubic here. Negative 1 is one of the roots. So this would be x plus 1 is one of the factors that would be in solution to this cubic here. So let's take that information, and now we can go into using long division. Well, to do the remainder, we can do long division. So we take our x plus 1, and we're going to divide that into our x cubed plus 6x squared plus 11x plus 6. We're putting that into this. I want to rewrite the original equation to see. We had, it's right here, x cubed plus 6x squared plus 11x plus 6 That is our original equation. So when we're doing long division, this is how long division works. We see x goes into x cubed, an x squared number of times. X squared times x is x cubed. X squared times 1 is plus x squared. We can put an invisible 1 here if that helps you. We are subtracting these just like we would in long division. X cubed minus x cubed is 0. 6x squared minus x squared is 5x squared. We bring down our plus 11x. Now we say, how many times does x go into 5x squared? Well, it goes in a positive 5x times. 5x times x is 5x squared. 5x times 1 is plus 5x. We again are subtracting both of these. 5x squared minus 5x, this is 0. 11x minus 5x is a positive 6x. Bring down our other term here, plus 6. How many times does x go into 6x? Well, it goes in 6 times. 6 times x, 6x. 6 times 1 plus 6, and we're left, if we were subtracting this, we would be left with 0. So we have that x plus 1 times x squared plus 5x plus 6 equals this cubic that we had up at the beginning. Now what we need to do is factor this binomial, this trinomial, polynomial. We need to factor this. Well, we've already got our x plus 1. And to factor x squared plus 5x plus 6 is x plus 2 and x plus 3. So our solutions are, if we set x plus 1 equal to 0, we have x plus 2 equal to 0 and x plus 3 equal to 0. That gives us that x equals negative 1, x equals negative 2, and x equals negative 3. These are the 3 roots of that cubic. Because there's a cubic, there's at least 3. There are 3, not at least 3. There are 3 roots to that cubic that will make that cubic equation be true. Okay? Let's see if we can do another example. Example 2, we've got x cubed minus 2x squared minus 6x plus 4. Okay, let's look for our a sub 0. Again, equals 1 because this is the invisible coefficient. And our a sub n equals 4. We're finding the roots of 1 and finding the roots of 4. Well, the roots here is just 1. The roots here, 1, 2, and 4. These are all the roots. Using the root theorem, plus or minus a sub n over a sub 0, which would give us plus or minus 1 over 1 is 1. Plus or minus 2 over 1 is 2, and plus or minus 4. We've got 6 roots from which we can work. Okay, so what we're looking to see is which one of these, first starting off, which one of these is going to make this cubic equal to 0. So if we put 1 in place, we've got 1 cubed minus 2 times 1 squared minus 6 times 1 plus 4. And does that equal to 0? Well, 1, this is minus 2 minus 6 plus 4. Does that equal to 0? 1 minus 2 is negative 1. Minus 6 more is negative 7 plus 4. Negative 3 does not equal 0. So 1 does not work. Let's see if negative 1 will work. We've got negative 1 cubed minus 2 times negative 1 squared minus 6 times negative 1 plus 4. Does that equal to 0? Well, negative 1 cubed is negative 1. Negative 2 times negative 1 squared is positive 1, so this is going to be minus 2. Negative 6 times negative 1 is plus 6 plus 4. Does that equal to 0? Well, negative 1 and negative 2 gives us negative 3 plus 10. This does not equal to 0. So let's go a little bit further. Let's see if positive 2 works. 2 cubed minus 2 times 2 squared minus 6 times 2 plus 4. Does this equal to 0? This feels like a bit of a long way around, but I believe it's a shorter way. 2 cubed is 8. Minus 2 times 4 is also 8. Minus 6 times 2 is 12. Plus 4, does this equal to 0? Well, these two are 8 minus 8 is going to be 0. Minus 8 more is negative 8. So negative 8 does not equal 0. So that one didn't work. Alrighty, let's see what about negative 2. Negative 2 cubed minus 2 times negative 2 squared minus 6 times negative 2 plus 4. Does that equal to 0? Negative 2 cubed is negative 8. Again, we have a minus 8 because negative 2 times a positive 4, negative 8. Plus 12 plus 4. Well, negative 8 and negative 8 equals negative 16. And 12 and 4, equals 16. These two do actually equal 0. Whoop, whoop. So negative 2 is a root that will work for us, which we would write that as x plus 2. If we're using the root x equals negative 2, it means x plus 2 is the root. So now we'll go back to long division using x plus 2 as our root and dividing that into our trinomial, which our trinomial is x cubed minus 2x squared minus 6x plus 4. That's our trinomial that our polynomial that we're dividing into. So we see how many times does x go into x cubed? Well, it goes in there x squared number of times. X cubed, x squared times 2 is a positive 2x squared. Put these together, we are subtracting. X squared minus x cubed minus x cubed is 0. Negative 2x squared minus 2x squared is negative 4x squared. Bring down our negative 6x. X into negative 4x squared goes a negative 4x number of times. Negative 4x squared. Negative 4x times 2 is negative 8x. Again, we're subtracting. Negative 4x squared plus 4x squared is going to give us 0. Negative 6x plus 8x is a positive 2x. We add our 4 here. X goes into 2x 2 times. 2x, 2 plus 2 is 4. Subtracting these, we have 0. So what we're left with is x plus 2 times x squared minus 4x plus 2. We need to factor this third term. And it doesn't look like that is easy to factor. So let's utilize a completing the square. See if that'll help us some. So we can get the second and third solutions. That means we're going to take x squared minus 4x, and we're going to set that equal to negative 2. By negative 2, we just move this positive 2. Let me show one more step in here. X squared minus 4x plus 2 equals 0. Here we go. And we're moving this 2 over to the other side, so that way we can save room here to complete the square. In completing the square, we have the b divided by 2 squared. This is a b, not a 6. This is the b term is negative 4. So we have x squared minus 4x plus negative 4 over 2 squared. This equals negative 2 plus negative 4 over 2 squared. This is called completing the square. So we have x squared minus 4x. Negative 4 divided by 2 is negative 2 squared is plus a 4. Negative 4 divided by 2 is negative 2. When you square that, you get positive 4. This equals negative 2 plus 4 over here. So now we have x minus 2 squared equals positive 2. In order to find the roots, you need to take the square root of both sides. Take the square root of both sides is our next move. So we have x minus 2 equals plus or minus the square root of 2. Plus or minus because there are two roots. So we have x minus 2 equals square root of 2, and x minus 2 equals the negative square root of 2. Solving both of these for x, we're adding 2 to both sides. X equals 2 plus the square root of 2, and x equals 2 minus the square root of 2. Two more solutions. To this cubic, we had x equals negative 2, x equals 2 plus the square root of 2, and x equals 2 minus the square root of 2. These are our three roots, three solutions to our original cubic of x cubed minus 2x squared minus 6x plus 4. These are the roots that satisfy that equation. Okay? So we have showed you how to solve a cubic based on the rational roots theorem, and then using long division. In this case, this last example, we also had to pull in our knowledge of completing the square in order to factor there, so we could get all three of our roots. I have something to share with you. Many students really struggle with taking tests and having a hard time when it's test time, practicing and preparing themselves for their test. Well, I've created a test bundle. This test bundle for algebra includes all kinds of topics that are in algebra: equations, graphing, inequalities, systems of equations, factoring, working with polynomials, working with monomials, so on and so forth. There are actually 34 practice tests in this bundle available for immediate download at 8minutemaths.com/test-bundles. This resource, 34 practice tests, is what I put together. I've given lots and lots of tests over the course of over 13 years of teaching math. And I see that test taking and assessments as exams is one thing that really makes or breaks a student. Their comfort level when it comes test time plays a big key role. And if they are not prepared for the test, they end up making minor errors and sometimes major errors. So these practice tests in this bundle will help you to practice things outside of the testing, the formal testing situation, where you can get comfortable and all that before you get to the test. Okay. So avail yourselves of that, 8minutemaths.com/test bundles. You can also just go to the website and pick on practice test bundles and go ahead and get that there. All right. I will see you in the next video. If this video has been helpful to you, then subscribe to the channel so you can be notified when new videos are posted. Also, visit us at 8minutemaths.com, where you can see our content and resources and courses, things that are available to you there. Lastly, follow us on Facebook at 8minutemathshelp.com. We look forward to seeing you there.